guys. Fine. So here we are going to have the revision session for the GATE 2025 for the subject electromagnetic theory. As you all know, electromagnetic theory is a core subject for the EC students. Fine. It will going to play a dominant role in your selection process. The marks will be especially for the GATE exam 8 to 14 marks. This is a variation if you observe the previous papers. Fine. So as it is a revision session, just I will going to list out the concepts here with and followed by the some associated numericals. So here is this is a syllabus here we are having. The syllabus here is a vector calculus and coordinate system, Maxwell's equations, EM wave propagation in the unbound medium, waveguides. In the waveguides, there is a rectangular waveguide, circular waveguide, and you can take the fiber optic cables and even the parallel plate waveguides also, and transmission lines and antennas. Undoubtedly, this is one of the more mathematical subject and requires some proper visualization in understanding the concepts. Fine. So even though it's the vector calculus part is not mentioned in your syllabus, this is a part of your mathematics, but generally this will be associated, this will be taken as a part of your electromagnetic theory. A vector calculus and coordinate system is a prerequisite, is a required thing to understand the concepts of electromagnetic theory. Fine guys. Now let us start with the vector calculus and coordinate system. See here in the vector calculus and coordinate system, let us start with the coordinate system. Let us have a fast recapitulation. These coordinate systems are developed based on how we are assuming this three-dimensional space. If you assume this unbound three-dimensional space as a box, that leads to the Cartesian coordinate system. If you assume it as a cylinder, that leads to the cylindrical coordinate system. If you assume it as a sphere, that leads to the spherical coordinate system. Let us have a fast recapitulation of the Cartesian coordinate system. Suppose if I want to locate some particular point P on the box, I need three coordinates. They are x comma y comma z. X here, y here, z here. Remember x cross y. We are following the IEEE standard, right-handed coordinate system. Fine. So let me check out. Are you all with me? Just raise your hands. Cartesian coordinate system here. So the x is ranging from x, y, z are ranging from minus infinity to plus infinity. X is from minus infinity to plus infinity. Y is also from minus infinity to plus infinity. Z is also from minus infinity to plus infinity. You must focus on the right-handedness here. X cross y is z. Okay, you need to follow this. X cross y is a z. Right-handed coordinate system. X cross y is z, y cross z is. That means if I move from right-hand fingers, if I move from my right-hand fingers from x to y, my thumb will be in the z, and so on. So whenever you draw the coordinate system, you must follow what is called a right-handedness. This is all about the Cartesian coordinate system. Then the cylindrical coordinate system. So here also coordinates are rho comma phi comma z. The rho is a radius. If I drop this one onto the xy plane, this is also rho. How much angle it is making is a phi, and the distance from here to here is a z. Clear, friends? And what is the rho? Rho is a radius. We will be starting from 0 to infinity. Phi is from 0 to 2 pi. Z is borrowed from the Cartesian. It is minus infinity to plus infinity. Okay. Here also rho, phi, z are orthogonal to each other. Rho cross phi is z and so on. Fine. Now can we do the conversions here? Yes, of course. So this rho is making the phi with the x-axis. So what is the x component here? X is equal to rho cos phi, and if I resolve other side, the rho other side, the rho sin phi. Anyhow, z is equal to z. Now I want to do reverse. From here you can say that rho is equal to square root of x square plus y square. If you take the ratio of these two things, it is tan inverse of y by x, and z is equal to z. Clear, guys? Next one is a spherical coordinate system. Okay. So here, if I want to locate some particular point P, I need three coordinates. What is the r? R is the radius of the sphere. Theta is the angle made with respect to z axis. If I drop this one onto the xy plane, whatever the angle it is making here, it is a phi. R, theta and phi. Fine. So where r is a radius starting from 0 to infinity, theta is from 0 to 5 and phi is from 0 to 2 pi. Remember, theta is only from 0 to 5, point to be noted. Okay guys, fine. Now can you do the conversions here immediately? Yes. You can notice here, this r is making theta with the z axis. So what is the z component? It is r cos theta. Now go back here, what is this OA length? This one is r cos theta, other side it is r sin theta. This r sin theta is making phi with the x axis. So what is the x component? It is r sin theta cos phi. If I resolve other side, r sin theta sin phi. Now I want to do reverse. You can check it out. So r is equal to square root of, you can check out, x square plus y square plus z square. What is this theta? Theta is cos inverse of z by r, where r is this one. And what is this phi? You can take the ratio of these two things. It is tan inverse of y by x. So this is all about coordinate system. Next one is the other thing what you need to remember here is the Stokes theorem and divergence theorem. What is the Stokes theorem will going to do? Stokes theorem will going to relate closed line integral with the open surface integral. Clear? So let us consider the vector field F here. When I draw a single vector field, you have to assume that in this region there is a vector field. Now there is a closed line integral here. So this is dl. This is a line direction. Inside this one there is a area dA. So you have to decide the normal direction. How? You have to put your fingers in the direction of loop, then your thumb will going to show the direction of normal. Okay guys? So this is a normal direction. So the area direction is a normal direction. So while you are using the Stokes theorem, you can decide the normal direction for the open surface uniquely with the help of right hand thumb rule. You have to put your fingers in the direction of loop. So your thumb is pointing outwards. Suppose if the loop is going in this way, then the thumb will be inside. Then what is the Stokes theorem is saying? It is closed line integral of f dot dl is equal to surface integral of del cross f dot dA. So this is a Stokes theorem. Stokes theorem will going to help us in converting the Maxwell's equations from differential to the integral form and vice versa. Next one is a divergence theorem. What are the divergence theorem will do? Divergence theorem relate the closed surface integral with the volume integral. Now let us consider the vector field F. Now consider the closed surface. It is something like a balloon. Let me put some dots here. Why I am putting these dots? To create the field that it is a three-dimensional one, something like a balloon. On this one, there is a surface. On the balloon, it is a patch. On this one, there is a surface. So the normal direction for this one is always outwards. Inside this one, there is a volume. Okay. So what divergence theorem is saying? It is a closed surface integral of f dot dA is equal to volume integral of divergence of f into dV. So this is a Stokes theorem and then divergence theorem. Clear guys? Now here is a question. Can you try this question? Given V is equal to x cos square y x I cap plus x square e to the power of z y cap plus z sin square y z cap and S, the surface of the unit cube with one corner at the origin and edges parallel to the coordinate axis. The value of closed surface integral of V dot n ds is. Okay. So what is asking us to do? Is asking us to find out the integral of interest is closed surface integral of V dot ds. See, he has written here elaborately, but area direction is a normal direction. Okay. So he is asking us to perform over the cubical region, which is placed like this 1, 1, 1, everything is 1. Okay friends, area direction is a normal direction, like this, like this, like this, like this. So you can make use of, suppose if you want to go by this one, you need to integrate over 6 faces. Instead of that, you can make use of what is called this divergence theorem. So divergence of V into dV. Clear guys? Fine. So what is this divergence of V? Divergence of V is equal to dou by dou x of x component. Differentiate this one with respect to x. It is cos square y, plus differentiate this one with respect to y. So it is 0. Differentiate this one with respect to z. It is sin square y. Cos square y plus sin square y is 1. Fine. So once you have got this one, you can make use of this integral. It is volume integral of divergence of V into dV. So you can substitute this one. It is 1 into dV. So this is volume integral of dV. This is nothing but a volume. Volume of the box, which is 1 into 1 into 1, which is equal to 1. Clear guys? So what is the answer for this is 1. Let us have one more question. If A is equal to xy x cap plus x square y cap, then closed line integral of ADL over the path shown below is, path is given in the question. So it's asking us to perform the closed line integral. Fine. So what is the closed line integral of ADL? If you go by this, you have to perform here integration over this, over this, over this, over this. Waste of time. Instead of that, you can make use of the Stokes theorem, which is surface integral of del cross A dot ds. Clear friends? So you have to make use of this one. Then what happens to the ds here? This is a small patch here. So this is x, this is y. So as I said earlier, how do you decide the normal direction? You have to put your fingers in the direction of loop. Your thumb will going to show the direction of normal. So this is x, this is y. Outside is a z. So what is the ds? It is dx dy z cap. Clear guys? So first find out. So I'll make use of this integral. Find out curl of A. What is the curl of A? X cap, y cap, z cap. What is the x component? It is dou by dou x, dou by dou y, dou by dou z. What is the x component? It is xy. What is the y component? It is x square. This is 0. Clear guys? So perform the curl here. Curl of A is equal to, can I write down directly? X cap into this minus this, 0 minus 0. Minus y cap into this minus 0 minus 0. Plus z cap into this minus this into this. It is 2x minus x. So del cross H A is equal to x into z cap. I'll going to turn the page here. So what happens to the integral? It is surface integral of, it is x z cap dot product with dx dy z cap. Clear guys? So what happens to this? This is surface integral of x dx dy. Separate out the variables. It is x into dx dy. Perform the integration. So this is x square by 2. X limits are from 1 over root 3 to 2 over root 3. Here 1 over root 3 to 2 over root 3. Y limits are from 1 to 3. Upper limit minus lower limit. You can take this 1 by 2 out. It is 4 by 3 minus 1 by 3 into 3 minus 1. Clear? So integral I is equal to 1 is the answer. Clear? Fine. Now let us have some standard forms here. We have some different formulas, different operators. What are they? A differential length, differential surface, differential volume, divergence, curl, gradient, Laplacian operator. So how many operators are there? Total 7 operators are there. Okay, friends. Electrostatics and magnetostatics are not part of your syllabus. Meghana, Maxwell's equations. From Maxwell's equations, you need to start. Okay, friends. Chalo. Okay, guys. So these are the 7 standard forms. So you need to remember these 7 formulas, which will going to help us in our electromagnetic theory in the 3 coordinate system. What are the 3 coordinate systems we have? Cartesian coordinate system, x comma y comma z. In the cylindrical coordinate system, rho comma phi comma z. In the spherical coordinate system, r comma theta comma phi. So 7 formulas into the 3 coordinates, in the sense 21 formulas. Instead of remembering like a 21 formulas, we have what is called as standard forms. 7 standard forms which will going to expand over the 21 formulas. See, you have to remember like this. There is something like a what is called the scaling factors. So coordinates and scaling factors, I will be talking in terms of UVW. For the Cartesian XYZ, for the cylindrical rho phi z, for the spherical r theta phi. So what are the scaling factors for the Cartesian? 1, 1, 1. For the cylindrical 1, rho 1. For the spherical 1, r sin theta. Clear, friends? So what happens to the differential length? The standard form is dl is equal to h1 into du u cap plus h2 into dv v cap plus h3 into dw w cap. Clear, guys? This is for the, suppose this is a general expression, generic expression. If you want to get it for the Cartesian, what happens? UVW are XYZ. Scaling factors are 1, 1, 1. Okay. So this will become dx x cap plus dy y cap plus dz z cap. For the Cartesian, what happens for the cylindrical? D rho cap plus rho into d phi cap plus dz z cap. That is for the cylindrical and so on. Similarly, what happens to the differential surface? A differential surface dA or ds, differential area or differential surface, h1 h2 du dv into w cap plus h2 h3 dv dw u cap plus h1 h3 h1 h3 h1 dw du v cap. So this is the differential surface. Similarly, you can, if you want it for the Cartesian, cylindrical and spherical, you need to substitute corresponding things. Similarly, what happens to the differential volume? dV is equal to h1 h2 h3 du dv dw. Clear, guys? So accordingly, you need to modify for the Cartesian, cylindrical and spherical. Next, a gradient. Gradient is performed on the scalar field. Just I'll represent it as a f. So the standard form for the gradient is gradient of f is equal to 1 divided by h1 dou f by dou u cap plus 1 divided by h2 dou f by dou v cap plus 1 divided by h3 dou f by dou w cap. So you can modify accordingly for the Cartesian, cylindrical and spherical. Next, divergence and curl. Divergence is performed on the vector field. Output is a scalar field. Curl is performed on the vector field. Output is a vector field. Now, let me define what is called here the divergence. So the divergence of f is equal to 1 divided by h1, h2, h3. A determinant of, not determinant here. Dou by dou u h2 h3 into fu plus dou by dou v h1 h3 into fv plus dou by dou w h1 h2 into fw. Clear, guys? Fine. Then what happens to the curl? Curl of f is equal to 1 divided by h1 h2 h3 h1 into u cap H2 into V cap, S3 into W cap, dou by dou U, dou by dou V, dou by dou W, H1 into Fu, H2 into Fv, S3 into Fw. So these are the standard form for the divergence and curl. You can expand these things accordingly for Cartesian, cylindrical and spherical. Next, last one is a Laplacian operator. Laplacian operator, I am defining it over the F. Just I am representing with the F. Scalar field. Fine. So which is a function of rho, U comma V comma W. Just I am representing as F. So it is a second order operator. So del square F is equal to 1 divided by H1, H2, H3. Dou by dou U. H2, H3 divided by H1. Dou F by dou U plus dou by dou V. H1, H3 divided by H2. Dou F by dou V plus dou by dou W. H1, H2 divided by H3. Dou F by dou W. Clear, guys? Okay, friends. So there is a rhythm. See, you can go back and check out differential length. This is a standard form. So you have to remember this table. Okay, guys? If you want, you can elaborate this one for the Cartesian, cylindrical and spherical. This is a table, scaling factors, coordinates and scaling factors, differential length, differential surface, differential volume, and then gradient. Divergence and curl, Laplacian. Fine. So let us take some questions on these things here. Now, the scalar field in certain region is defined as r square sin theta cos phi. The magnitude of the gradient at a point 1 comma pi by 4 comma pi by 4 is. Fine. So, is asking us to find out the gradient. What is the gradient formula in the spherical coordinate system? Gradient of f is equal to dou f by dou r cap plus 1 by r into dou f by dou theta cap plus 1 by r sin theta into dou f by dou phi cap. Clear, friends? So what happens to the gradient of f? Differentiation of this one with respect to r. So it is 2r sin theta cos phi r cap plus differentiation of this one with respect to the theta. Yes. So it is r square cos theta cos phi theta cap plus 1 by r sin theta. Differentiation of this one with respect to the phi. So which is minus r square sin theta sin phi cap. Clear, friends? So the gradient of f is 2r sin theta cos phi r cap plus r cos theta cos phi theta cap minus r sin phi cap. He is asking at that point, substitute here r comma theta comma phi. So gradient of f is equal to 2 into 1 into 1 by root 2 into 1 by root 2 into r cap plus 1 into 1 by root 2 into 1 by root 2 into theta cap minus 1 into 1 by root 2 into phi cap. I will going to turn the page here. So what is the gradient of f, guys? It is r cap plus 1 by 2 theta cap minus 1 by root 2 phi cap. It is a numerical answer type question. So the gradient of f is asking magnitude. What is the magnitude? Square root of 1 square plus 1 by 2 whole square plus minus 1 by root 2 whole square. Now can you evaluate this one? How much is this? Square root of 1 plus 1 by 2, 1 by 4 plus this is 1 by 2, that can be written as 2 by 4. So which is, this one is 8, not 8, 7 by 4. Am I correct? So it is root 7 by 2. How much is this, guys? Root 7 by 2. 1.32. Okay, guys? Okay, fine. Let us have next one more question. Here is a question, guys. Only thing is, this kind of questions with the formula you can find out. So it f of rho comma phi comma z is equal to rho cap plus rho sin square phi cap minus z cap. Which of the following is true? Here it is in the cylindrical coordinate system. Only, and is asking at the three different points. At phi is equal to 0, pi by 4 and pi by 2. Fine. So find out its divergence, guys. So what is the divergence of f formula? It is 1 by rho into dou by dou rho into f rho plus dou by dou phi into f phi plus dou by dou z into rho into fz. Clear, guys? So you can substitute there 1 by rho into dou by dou rho into f rho is rho. Dou by dou phi into f phi. What is f phi? It is rho sin square phi. It is rho sin square phi plus dou by dou z into rho into fz. What is fz? It is minus z. So 1 by rho into rho square. Rho square differentiation is 2 rho plus this one rho into sin square differentiation is 2 sin phi. Successive differentiation is cos phi. Differentiation of that one is minus rho. So you can check out divergence of f is equal to this 2 rho minus rho. What remains is a rho. It is 2 sin phi cos phi. This can be written as 1 plus sin. Just it is algebra 2 sin phi. It is asking at the three different points. At phi is equal to 0. So divergence of f is equal to 1 plus sin of 0. Sin of 0 is 0, which is 1. At phi is equal to pi by 4. Divergence of f is equal to 1 plus. It is sin pi by 2, which is 1, which is equal to 2. Is also asking at one more point, at phi is equal to pi by 2. Am I correct? At pi by 2 also, yes. So divergence of f 1 plus sin into 2 into pi by 2. It is sin pi, it is 0. So which is equal to 1. So you can check out option D is the correct. So at this is 2, at 0 it is 1, 2 times this one. One more question, guys. The magnitude of the curl of a vector field f of rho comma phi comma z is equal to 1 by rho into phi cap is. Okay, friends. So this is in the cylindrical coordinate system. What is the curl formula in the cylindrical coordinate system? Curl of f is equal to 1 by rho into rho cap, rho into phi cap, z cap. Dou by dou rho, dou by dou phi, dou by dou z. F rho, rho into f phi, it is fz. Okay, guys. Which component it is? It is a phi component. Phi value is 1 by rho. So this is 0 here, this is 0 here. What is this one? It is 1 by rho. So resultant will be 1, 0, 1, 0. Differentiation followed by the constant, which is equal to 0. You can check it out. Okay, next chapter. That is all about this coordinate system. Okay. So what we have seen here, these are the things need to be remembered from the first chapter. Vector calculus and coordinate system. These are the important points. Cartesian coordinate system, cylindrical coordinate system, limits, and then spherical conversions, and then spherical coordinate system. Must be careful, theta is ranging only from 0 to 5. So, and conversions, Stokes theorem, divergence theorem, and then 7 standard forms, okay, which will going to expand over 21 formulas: divergence, curl, gradient, Laplacian operator, differential length, differential surface, differential volume. So, you have to remember this box along with the 7 standard forms. In every equation, there is some rhythm: H1, H2, H3. H2, H3 is missing, H1 is missing, H1 is missing, H1, H2, H2, H3, H3, H1. So, there is some rhythm. H1, H2, H3 divided by H1 divided by H2 divided by H3. H1 is missing, H2 is missing, H3 is missing. H1, H2, H3. Scaling factor 1 by H1, H2, H3. So, here divided by H1 divided by H2 divided by H3. So, in every equation, there is some rhythm. Okay, guys. Next one is the Maxwell's equations. Let us proceed further. Maxwell's equations. So, there are two different forms of the Maxwell's equations. One is the differential form, other one is the integral form. So, what are the differential form of Maxwell's equations? Number 2, del cross H is equal to J plus dou D by dou T. The other one, del cross E is equal to minus dou V by dou T. Third one, divergence of D is equal to rho V. Fourth one, divergence of B is equal to 0. These are called differential forms. And there is other form, what is called an integral form. How can you convert from differential to the integral? By using Stokes theorem. So, it is closed line integral of HDL is equal to surface integral of J plus dou D by dou T into dA. Next, number 2, closed line integral of EDL, which is equal to minus surface integral of dou V by dou T into dA. Next, number 3, closed surface integral of dDA is equal to volume integral of rho V into dV. Number 4, closed surface integral of BdA is equal to 0. Let us try to have some interpretation of these things. So, there will be, damn sure there will be one question. 99% there is a chance of getting the questions on. So, 99% there are chances of getting the question either from this Gauss law, okay, or from the Ampere's law, from the Maxwell's equations. So, 99% there will be one question on the Maxwell's equations. So, what these third and fourth equations are called? These are called source equations. That means, to put it in a simple way, it is saying that the source for the electric field is charged, the source for the magnetic field is also charged, but dipole charge, net charge in the system is 0. So, these are called coupled equations. So, these equations are explaining the relation between electric and magnetic field. Change in electric field is giving magnetic field is giving electric field, and so on. Okay, guys. Chalo. Now, how can you modify these? Even the static fields also important. Static field is in the sense dou by dou T is equal to 0. There is no variation with respect to time. So, how can you modify these equations for the static case? Wherever you have dou by dou T, make that one equal to 0. So, here del cross H is equal to J. Second one, del cross E is equal to 0. Third one, divergence of D is equal to rho V. Fourth one, divergence of D is equal to 0. And similarly, how this can be modified? It is closed line integral of HDL is equal to surface integral of J dot dA. Next, closed line integral of EDL is equal to 0. Third one, closed surface integral of dDA is equal to, it remains the same, volume integral of rho v into dV. Fourth, closed surface integral of B dot dA. So, on these things, there will be a question. There are chances of getting question on Maxwell's equations. You should know the theoretical background of each and everything. So, here is a question, here is a question, here is a question, and here is a question. Okay, guys? Yes. Shall we take the questions? An electrostatic field, the electric displacement density vector D is equal to, D is given. Okay. Consider the cubical region R centered at the origin with each side of length 1 meter and vertices at x comma y comma z ranging from minus 0.5 to plus 0.5. The electric charge enclosed within R is dash coulombs. So you need to use what is called a Gauss law here. It is asking for what is called a charge enclosed, ENC. According to the Gauss law, charge enclosed is equal to net electric flux, which is nothing but closed surface integral of dDA. Okay, guys? Never perform the closed surface integral, it is a time taking. Instead of that, make use of what is called a divergence theorem. This is nothing but this one only. This is a max. Closed surface integral of dDA is a net electric flux, which is equal to charge inside that, volume charge. Yes, friends? What is this divergence? You can also think in other way. So, what is the divergence of D is a rho v. So, when you perform divergence of D, you are getting what is called a volume charge. To get the total charge, charge enclosed inside that cubical region, you need to perform the integration. Bas khatam. So, find out the divergence of D in the first step. So, you have to make use of this integral. So, find the divergence of D. Divergence of D is differentiation of this one with respect to x, it is 3x square plus differentiation of this one with respect to y, it is 3y square. Differentiation of this one with respect to z, it is plus 0. So, divergence of D is equal to 3 into x square plus y square is equal to rho v. So, what is the total charge E enclosed? It is, you have to perform the volume integral of 3 x square plus y square into dx dy dz. Clear? Now you can bring this one into the inside, it is x square into dx dy dz. Dx dy dz. Separate out the variables. X square into dx dy into dz. Perform the integration. Minus 1 by 2 to plus 1 by 2. Minus 1 by 2 to plus 1 by 2. Minus 1 by 2 to plus 1 by 2. This is x. Minus 1 by 2 to plus 1 by 2. Y cube by 3. Minus 1 by 2 to plus 1 by 2. This is z. Minus 1 by 2 to plus 1 by 2. Upper limit minus lower limit. This 3 will cancel out. Okay. So, it is x cube 1 by 2 cube, it is 1 by 8 minus of minus. So, it is 2 by 8 into 1 into 1 plus this one, guys, the same thing, 3 will cancel out. So, this will remain 1 into 2 by 8 into 1. So, this is 4 by 8, which is 0.5 coulombs. 0.5 coulombs is the answer. Clear? Fine. Let us have one more question. Here is the one more question. Yes, guys. Come on, try to answer this one. Again, this question is also based on the Maxwell's equation. Given the equation represents the magnetic field strength h of r comma theta comma phi in the spherical coordinate system in the free space. Okay, the value of the P in the equation should be dash. So the h is given. Fine. So what you know from the Maxwell's equations, divergence of B is equal to 0. You have to make use of this. Okay, guys. So what happens to this here? Divergence of B is equal to 0. It is said that it is satisfying for the free space. Generally, B is equal to mu naught into h, mu into h. For the free space, what happens? It is mu naught into h. You can bring this one and substitute here. So divergence of mu naught into h is equal to 0. Mu naught is a constant, you can take it out. Mu naught into divergence of h is equal to 0. So here divergence of h is equal to 0. I am going to turn the page. So divergence of h is 0. So use the divergence formula. Divergence of h is equal to 1 divided by r square sin theta dou by dou r square sin theta is in the formula into hr. What is the hr component? It is p cos theta by r cube. Plus dou by dou theta. Theta is, it is dou by dou theta. In the formula, it is r sin theta into sin theta by r cube. Plus dou by dou phi. Yes, into this one is r into h phi. H phi is, there is no phi component. So this is 0. Yes, guys. So can you write down in a single, this is equal to 0. That is important. Divergence of h is equal to 0. It is a spherical coordinate system. That is the reason I have given the 7 standard form. R square sin theta. What is the differentiation, guys? Here it is. Can I write down directly? So it is 1 by r. It is sin theta cos theta. It is P sin theta cos theta divided by 1 by r. 1 by r differentiation is minus 1 by r square. I have written directly. So in the denominator it is 1 by r square. In the numerator it is sin square. What is the sin square differentiation? 2 sin theta cos theta divided by r square, which is equal to 0. Clear, friends? So make this part equal to 0, which is P sin theta cos theta divided by r square, which is equal to 2 into sin theta cos theta by r square. So from here one can say P is equal to 2. Just have skip the sum of the algebra. So the P value is 2. It was a numerical answer type question from the electrical paper. Anyhow, there is one more question. This is on the Ampere's law. Which Maxwell equation you have to use? First Maxwell equation. Go back. This one. So MMF in the loop is equal to current enclosed here. This one. These are current, conduction current, displacement current in general. If it is a static case, only conduction current. Okay. So he is asking us to find out the current here. So it is only dependent on the space. It is not dependent on the time. So if it is not dependent on the time, so the Ampere's law is actually definition form for this one is MMF in the loop is equal to current enclosed. So I ENC is equal to MMF in the loop. Just I am elaborating that, which is closed line integral of HDL. But here there is a loop. Where the loop is placed? This is x-axis, this is a y-axis, this is a z-axis. The loop is placed in the xy plane. This is how the loop is placed. So if the loop is placed in the xy plane, what happens to the differential area? dA is equal to dx dy z cap. This is a loop is placed. The loop is having the total 4 sides. If you go by this, you have to perform the integration 4 times. Instead of that, you can make use of Stokes theorem. Surface integral of del cross H dot dA. You can think in other way, del cross H is equal to J. Okay guys, so you can think in other way, del cross H is equal to J. So it is something like you will find out what is called a conduction current density. Then for the total current, you will find out the surface integral. Okay, you can even think in that way. You can think in terms of the Stokes theorem, or you can think in terms of the current density. So for some of our friends rightly said. So let us try to find out. So the del cross H, guys, it is determinant of x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. What is x component? It is minus y x square minus y cube. It is x cube plus xy square. This is 0. So x cap into this minus, it is 0 minus 0. Minus y cap is this into this minus this into this, 0 minus 0. Plus z cap is this into this, it is 3x square plus y square minus x square minus 3y square. So del cross H, which is also equal to J, is equal to 4 into x square plus y square is z cap. Units are ampere per meter square. So I, E and C enclosed, you have to perform the surface integral of this one, which is 4 into x square plus y square into z cap, dot product with dx, dy, dz, z cap. Okay guys, so after performing the, so this will become surface integral of 4 into x square plus y square into dx into dy. Bring this one inside, it is 4 into x square into dx dy plus 4 into y square dx dy. Perform the integration. Yes, so it is 4 into x cube by 3. X limits are from minus 1 to plus 1. It is y limits are from minus 2 to plus 2. X limits are from minus 1 to plus 1. Y cube by 3, y limits are from minus 2 to plus 2. Upper limit minus lower limit. You can take 4 by 3 out. So it is 1 minus of minus 1, it is 2. 2 minus of minus 2, it is 4. Plus this one, 1 minus of minus 1, it is 2. 8 minus of minus 8, it is 16. So it is 4 by 3 into this is 8, that is 32. So it is 40. 160 by 3, which is 53.33 amperes is the answer for this. Okay friends, let us have one more question. Here is a question guys, this is on the Faraday's law. There was no numerical so far in your exam on the Faraday's law. Most of the questions when it comes to the Maxwell's equations, the questions was on the Gauss law, on the Ampere's law, fine. But we'll touch this one also. The square loop of Bohr meter side is placed in the xy plane with its center at the origin and sides along the coordinate axis. If the magnetic flux density in the region is given by V is equal to 0.2 x cap minus 0.3 y cap plus 0.4 z cap into e to the power of minus 0.1 into T Weber per meter square. Find the induced EMF in the loop at time t is equal to 10 seconds. See here guys. So there is a loop here placed in the xy plane. These are x, these are y, these are z. So it is a negative x, negative y. There is a loop here. So this is having a side 4 meters. This is 4 meters. Then what happens to the differential area? Dx dy z cap. In this region, there is a magnetic field B. He is asking what is the EMF induced. EMF induced in the loop, or simply V, is equal to closed surface integral of closed line integral of E dot dl, because in the loop, closed line. But according to the Gauss law, Faraday's law, it is equal to surface integral of dou V by dou T into dA, means this one. So you have to make use of this one. EMF in the loop is equal to rate of change of magnetic flux. Fine. So you have to make use of this integral. Okay, guys. Maxwell's equations are, see, these are the Maxwell's equations. This was proposed by the Maxwell. This displacement current concept was proposed by the Maxwell. So this is Ampere's law, generalized Ampere's law. This is a Faraday's law, Gauss law for electric field, Gauss law for magnetic field. Yes. So what it is saying in a simple words is, the source for the electric field is charge, the source for the magnetic field is also charge, but what kind of charge? Dipole charge. So the time varying magnetic field is giving space varying electric field. Magnetic field is due to two currents, conduction current and displacement current. So this is a simple, fast description of the Maxwell's equations. Okay, chalo. Okay, so I'll make use of this integral, guys. So what happens to this, which is minus surface integral of dou by dou T of B. What is the B beta? This entire thing. So it is 0.2 x cap minus 0.3 y cap plus 0.4 z cap into e to the power of minus 0.1 into t. Dot product with the loop is in the xy plane. So what is the differential area? It is dx dy. It is dx dy z cap. Now bring this differentiation with respect to the time outside. It is minus dou by dou T of e to the power of minus 0.1 into t. So it is 0.2 x cap minus 0.3 y cap plus 0.4 z cap. Dot product with dx dy z cap. So here z component, this dot product will remain. So what is the differentiation of this part? It is minus of minus 0.1 into e to the power of minus 0.1 into t. So surface integral of it is 0.4 into dx dy. Bring this one outside. It is 0.1 into 0.4 into e to the power of minus 0.1 into t. So it is dx dy. This is the area of the loop. So what is the area of the loop? It is 4 by 4. 0.1 into 0.4 into 4 into 4 into e to the power of minus 0.1 into t. So it is 0.64 into e to the power of minus 0.1 into t. He is asking at time t is equal to 10 seconds. At time t is equal to 10 seconds. Substitute there. So V is equal to 0.64 into e to the power of minus 0.1 into 10, which is 0.64 into e to the power of minus 1. So can you check out this value? 0.64 by e, approximately 0.23 volts. Am I correct? 0.23 volt is the answer.